Today we are going to take up the topic that is alkali metals. As you know, the S block element is converted into two groups of metals, that is your alkali metals and alkaline earth metals. First we are going to catch up with the alkali metals. For that, you know that the alkali metals have the electronic configuration NS1 maximum. NS1. Now when we talk about the atomic and ionic radii, the atomic and ionic radii increases with increase in atomic number and the atoms become larger in size. So when we go down the group, every time for every element, what happens? One shell is increased. So if we go on increasing one shell, the size of the atom will also increase, right? Therefore the atomic and ionic radii is also increasing. Next, if we talk about the ionization enthalpy, so ionization enthalpy is basically the energy required to form ions, and when we can form ions, when we will remove the electrons, right? So if we take the basic concept here, the positive charge or the proton or the nucleus is inside, right, in the middle, the center, and the electrons are distributed around it in the orbits. If the shells are always increasing, the outermost electron is far away from the nucleus. There is less attraction, so these electrons can be removed easily. There will be less amount of energy required to form ions, and hence the ionization enthalpy decreases, because the energy requirement is also decreasing, because you don't have to put much effort in order to remove these electrons, because the positive charge is very far away now, right? Therefore as we go down the group, the outermost electron or the valence electrons always move away from the nucleus, and in that way the ionization enthalpy always decreases down the group. This thing you have to remember. Now let us come to the reactions of the alkali metals. If we talk about the reaction with air, so let us take lithium. If lithium is reacting with oxygen, so when we say air here, we basically mean to say reaction with oxygen, because it is not specified here. So we will take oxygen as the reagent. So lithium plus oxygen will give us lithium oxide, and the formula is Li2O. Now you have to balance it. Since Li2O is there and 2 oxygen is there, so we will put a 2 here in order to balance out the reaction oxygen. So this oxygen is satisfied, but here 4 lithium has come up, so we will put a 4 here. So like that you have to know how to balance the reactions. Next, if we talk about sodium, we will get sodium peroxide. When 2 oxygen binds with 2 electropositive elements then we will say that it is a peroxide compound. So you can see here Na2O2. So there are 2 oxygen binded with 2 sodium. So these are the peroxide formula. So sodium will react with oxygen to form peroxide, while lithium will form the oxide. Next, reaction with water. When sodium reacts with water, or if you hydrolyze sodium, you will get sodium hydroxide, NaOH, okay, plus what is remain? H2 is remain. Next you have to balance it by using to both sides. If we take potassium along with water, we will get potassium hydroxide. So if we use water with these alkali metals, we are getting hydroxide, sodium hydroxide, potassium hydroxide, lithium hydroxide, all this, okay. So this thing you have to keep in mind. Next, reaction with hydrogen. Na plus H2, sodium plus hydrogen. What we will get? We will get a hydride, sodium hydride, okay. And then the balancing is very easy, because there are 2 hydrogens. So in order to balance this side, we will put a 2 here. But again, now this sodium here, it becomes 2, and here it is 1. So we will put a 2 here while balancing. Again, for lithium, you see, we will get lithium hydride, LiH. You have to pronounce such way, lithium hydride, sodium hydride. Now we know that when alkali metal reacts with air or oxygen, we will get oxide, peroxide, sometimes superoxide, like for potassium, cesium, rubidium. So we are going to get superoxide for those metals. But with water we will get hydroxides, and with hydrogen we will get hydrides.